So this is the worst relay race Windows update handoff ever.
Windows knows that when the worst time to update your computer is, and then it does that.
Well, at first it took everything away, and then I'm like, fine, I'll rebuild. I've been here before.
We will rebuild.
We will. And then I spend the time doing all of that, and then as soon as I'm done doing that, it says, oh, we need to restart. And so I restart, and it gives me back the old stuff, but all the new stuff that I did, gone. Just gone.
It's because Windows hates you, because Windows is a jerk.
And now my scrolly wheel, the scrolly wheel at my mouse, which I used to be able to scroll through as though reading text, is now going like half pages at a time. Like, why mess with that? Nobody complained about that. Did people say, "Oh, my mouse scrolls too slowly"? So
that's what Windows is famous for, is
volumes of
changing
text
things
with it.
unnecessarily. That's Windows' thing.
Oh my goodness! And so now I've got all the stories that I had prepared are now missing.
They are in the rundown.
The
not
stories
missing.
are in the rundown.
They're
My
not
preparation
missing.
isn't.
Your preparation notes are missing. The edits you made are missing. That is unfortunate. But the stories are here.
Yep.
We have the foundation.
Yeah.
We have the power.
Do you have the disclaimer? Because really,
Yes.
that's all you need right now in this very moment. Because I'm not going to let you sit here and rewrite your notes.
Yes.
We're starting the show.
Almost found my stories. Relax yourself.
Okay.
We're already late. I mean, how much more late
Justin?
can we be?
Justin, I really
Ladies are sleepy.
Ladies, we just want to do this show for our audience who have been waiting
I got a disclaimer ready to go.
for over 20 minutes.
I've been ready. I don't know what the holdup is.
You son of a Windows.
I'm just waiting for the intro to this show. Oh, also, where is the chat room? I don't have a chat room anymore.
Oh, jeez.
Go find yourself a chat room. All right. Justin?
What is it? What's the IR? What
Kiwi
is it?
IRC. Kiwi IRC. Yeah. And you look for
Hashtag TWIS.
Hashtag TWIS. Give yourself a guest name and hashtag TWIS.
You're welcome, Kiwi IRC. Free plug.
Yeah, anyone who wants to join our chat room, if you're watching right now, Kiwi IRC. Hashtag TWIS. Or the chat room I'm in is still webchat freenode. Webchat.freenode.net.
See, that one stopped working for me a while ago.
It just didn't work once, and then it worked great again. So all the pathways, the habits I have built do not have to be rebuilt.
Back to the rebuilding.
Back to the rebuilding.
Sensing a motif. All right, let's start. Let's start this show.
We're going to do this show now. You ready, Justin? You got your disclaimer?
I've been ready. Like I said, I've just been
ready.
Yeah.
Likely story.
I was born ready. We're going live in 3, 2. This is TWIS, This Week in Science, episode number 551, recorded on Wednesday, January 27th, 2016. Computer says go. Hey everyone, I'm Dr. Kiki, and this is This Week in Science, back once again to fill your heads with a tricksy computer, fertile faces, and bigger, better brains. But first.
Disclaimer, disclaimer, disclaimer. Just a few days from now, America will begin voting in the final candidates for the 2016 election. And as with every U.S. election, the fate of the world hangs in the balance. It matters who will win this election. How they lead will steer the course of our domestic spending, our foreign involvements, and will likely confirm 2 or more Supreme Court justices who will leave their mark upon the laws of the nation for generations to come. But why would any of this matter to the world of science? Science is neither progressive nor is it conservative. Science does not involve itself in matters of ideology. Science is just science. It deals with matters of evidence, and it does not take heed of public opinion nor care if it defies supernatural beliefs in its results. One does not poll a population to find a popular position in science. You follow the scientific method to a result, and the result becomes popular by its reliable reproduction. So without delving into the political sphere too far, if there is a political ideology or politician that seems determined to talk past science, as one might disagree with an ideological viewpoint of another side, beware, wary, very way wary even, for the enemy of science is the enemy of reality, and what they would have you accept in its absence is nothing like what you are about to hear on This Week in Science. Coming up next.
I've got the kind of mind I can't get enough. I wanna learn everything. I wanna fill it all up with new discoveries that happen every day of the week. There's only one place to go to find the knowledge I seek. I wanna know what's happening. What's happening? What's happening this week in science? What's happening? What's happening? What's happening this week in science?
Good science to you, Kiki and Blair.
And good science to you, Justin, Blair, and everyone out there. Welcome to another fantastic episode of This Week in Science. We are back again with science. Justin, I'm glad that you're better. So sorry that you couldn't join us last week.
Yeah, it was rough times.
Yeah, so we'd like all of your notes from last week's show. Kidding!
Kidding! On this week's show, we have all sorts of great stories to fill your minds with awe and wonder and science. I have new stories about consciousness itself, an artificial intelligence game master, and tooth sweaters. Justin, what do you have for us?
I've got lubricating balls and a duck-billed tail of two Americas.
Wow. Okay, letting that one go. Blair, what do you have in the animal corner?
Yeah. I have a couple different types of animal brains. I also have zebra stripes and a tegu.
A tegu.
Tegu.
We gotta talk about what that is.
Oh,
we'll talk about that later.
You're supposed to say, bless you.
Tegu.
Tegu.
Gesundheit. There we go.
There you go. There you go.
There we go. We got it.
We didn't rehearse. Sorry.
Okay, everybody. This brain-filled show is getting going. All right. So my first story is a brain story. Yes, there is evidence amassing. One study in 2014, and then another study that was just published, actually some autopsies that were described in the Swiss Medical Weekly this month, are amassing evidence that Alzheimer's disease, in certain cases, might be transmissible.
Whoa.
And then, like, what? How? What? Transmissible? If I touch somebody, is Alzheimer's gonna jump into my brain? Am I gonna start forming plaques and losing my memory? No, that's not how it's going to work at all. And in the autopsies that they did, what they were looking at were people who died of a brain-wasting disease called Creutzfeldt-Jacobs disorder, or CJD disease. And CJD is a prion disease where it's based on these crooked proteins, these prions that they fold crookedly, and they keep cells from functioning the way that they need to function. And so these prions get into the brain, cause the neurons to gunk up, and people usually die fairly quickly after getting the disease. In addition to the CJD, these cadavers also had evidence of Alzheimer's amyloid beta protein plaques building up in their brains. And some of the individuals were very young, in their 20s and 30s, so young enough that you wouldn't expect them to have amassed any plaques of any kind at that point in their life. You know, the Alzheimer's is a disease of the aged and not a disease of the young, so to see these plaques was a little odd. What happened to they think trigger the Alzheimer's is that the prion protein that gave the recipients the Creutzfeldt-Jacobs disease might have transmitted the Alzheimer's as well. Or another possibility is that the patients these patients who got, this is another twist to the story that's really interesting, the patients who had this Creutzfeldt-Jacobs disease, they had received the dura matter from cadavers. So the dura matter is just the thin covering over the brain. It's like a membrane that covers the brain. And these people were donated cadaverous dura matter. And it just so happened that those cadavers, they find out after the fact, had Creutzfeldt. After the fact, they had Creutzfeldt-Jacobs, and it was the Creutzfeldt-Jacobs was transmitted through this dura matter donation. They think that maybe the amyloid beta particles, that there might be some very sticky particles that are getting transmitted additionally along in the dura matter to cause the Alzheimer's disease. The worry here, if it is transmissible, is that the components that we're looking at, these proteins, these sticky proteins, these amyloid beta proteins, they don't wash off in standard sterilization procedures. So if somebody comes in and has this Creutzfeldt-Jacobs or the Alzheimer's, and if Alzheimer's is transmissible and you're operating in the brain, and then you go and you operate in somebody else's brain and you think you've sterilized everything, maybe you haven't.
Oh no.
So all of the areas have not been looked into yet. So we do not know if this is a possibility. It could be that it all comes from the Creutzfeldt-Jacobs prions. Could be that that is causing all of it. It could be that there's something else involved entirely. It could be that these random people did for some reason. You know, it's a small sample size. They're only looking at, a handful of people. Could be that they just happen to have early onset Alzheimer's.
Mm-hmm.
We don't know. So,
wow.
Yeah. So, ongoing research.
We need to figure that out. We need to figure it out. Stat.
Yes. I mean, the whole idea, though, that there are these proteins that are, they're so sticky that they just, you're not going to get rid of them. They're not going to come off of your surgical equipment with the standard procedures, and that you might have to up your game when it comes to sterilization. It's an interesting idea. Yeah. And then for our CRISPR alert.
We need like some flashing lights.
CRISPR alert.
Yeah. Well, I talked last week about the patent hubbub, the furor, the history that's ongoing. That is still ongoing. People are still really talking about that. But I thought we should really talk about what people are doing with CRISPR this week. And really interesting study. Researchers at Columbia University Medical Center and University of Iowa have used CRISPR-Cas9 to repair a genetic mutation that is responsible for an eye disease that it's a deteriorating eye disease called retinitis pigmentosa. It's inherited, leads to blindness. There are millions of cases worldwide, and they have, in stem cells, retinal stem cells, fixed the mutation using the CRISPR-Cas9 system. What this means is that this kind of technology is kind of cool, because I believe it's retinitis pigmentosa that we've reported on before that people are working on doing stem cell therapy.
Mm-hmm.
excuse me, are working on doing this stem cell therapy to treat it. And so to be able to take a patient's own cells, to be able to fix the mutation in the stem cells, and then to be able to put them back into the patient and potentially fix the problem, fix the disease.
Nice.
That is super cool. So this is a very interesting potential direction for this to go, and we hope that in the next few years we will definitely see researchers working on this this really great therapy for retinitis pigmentosa. Very
Nice.
cool, right?
Yeah.
Yeah. And then finally, for my intro stories, this one, oh my goodness. Oh my goodness. The computers are winning.
At?
Go!
No, you go.
No, you go. Go.
No, you.
A Chinese game called Go.
What is this
Oh.
game? Wait, what does this game go?
It is a Chinese game. It is a very complicated game. People say that it is more complex than the game of chess. And in an example of how complicated it is, in the game there are many pieces that you put on a board, and with those pieces that you put on the board, you try and surround the other player's pieces so that you end up holding the board, and it's a game of strategy, and there are many places to place your little stones.
So it's not Othello. It looks like the same pieces that you use in Othello.
It's not Othello.
But it's not. It's a different. Okay.
It's much more complicated, and people have calculated the number of possible piece placements on the board at something around 10 to the 171st power. So that's 10 with 171 zeros after it. I mean, it's just it's possibly more possibilities than there are atoms in the universe. No.
Sure, right. But then at some point, it's also like, okay, yeah, if you had chimps in the lab and you could just train them to place pieces, but they weren't being strategic about it, there's probably much fewer like strategically useful moves that you can make in this game.
Potentially,
I mean,
and so
just decorating the board shouldn't count.
Well, this particular game, it was estimated that computers, artificial intelligence, would not be able to beat a human for at least another decade. It's so complicated. However, Google's DeepMind project created a computer called AlphaGo. It's a system that, through trial and error, played a whole bunch of games against itself, basically, and it was given a number of games in its library to begin with. So its creators said, "Hey, here's a bunch of games that people have played, and these are all the moves that they made, and these are the outcomes." And then they gave AlphaGo a couple of rules that it had to use. So in its human approach to the game, it had to use what was first a policy network, so to be able to search only the moves that are most likely to lead to a win. So not all possible moves, but the ones most likely to lead to a win.
Narrow it down.
Yeah, and then the second is a value network, which estimates a winner from each move made. So the computer doesn't have to search all the way to the end of the game to at every move. It doesn't have to calculate the whole game at every move. It can calculate only one move at a time.
And then it can snark talk too. Then it can be like, "Are you trying to lose?"
Yeah. The researchers say the search process itself is not based on brute force, which is, just calculating everything. It's based on something more akin to imagination. So after its self-coaching, it played thousands and thousands of games with itself, and then it was ready to go. It won against the European 3-time Go champion, and I think it won 5-0. So it
really won.
It really won. Yes. And so the next game is going to be up against the world champion. I say he, I don't know why I did that, but AlphaGo will be up against the world champion. And so I don't. The big question here is what does this mean? I mean, this is a decade earlier than anyone expected that an artificial intelligence would be able to master this game and beat a human.
I think it just goes to show computers are going to be better at otherwise meaningless tasks than us humans.
But we made the computers.
Yeah. Well, no.
we're
You and I
still
didn't.
winning.
Blair, first of all, Blair, you and I didn't. People who are tuned to monotonous tasks created the computers.
Yep.
Okay. So the fact that the computer is good at monotonous tasks of learning monotonous things that are no use to itself isn't surprising. This just actually seems like just a continuation of the type of knowledge it's been given.
It is an example, exactly. It's an example of the type of knowledge, what it was trained to do, but it just means the artificial intelligence software, the program itself, is a very good program. This is a very accurate, intuitive AI to be able to have done this, and so now is this going to lead to new developments in medical diagnostics, our climate change models, maybe, is it going to make, the technology that we use every day better?
Mm-hmm.
Because this AI is that good, how is it going to be applied? So we will see.
Yeah, it sounds like it's a machine, it's technology that can respond to the other player is really what it's good at. So that's extremely applicable to what we need robots to do.
Absolutely.
Yeah.
Absolutely. Oh, robots, AI, you can play our games, you can write our newspapers. Why do we
write our newspapers? Yeah, that's probably.
Why do we even need to be here anymore?
The newspapers though then would just be covered in pictures of cats. Because they know that's what we want, and that's what a computer, given nothing but the internet, came up with was, oh, I guess you guys like pictures of cats.
La 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 la, kitty cat. La 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 la, kitty cat.
Yep.
This is This Week in Science. Justin, what you got?
Good question. Let's hope there's something here. Aha! So cars, driving them, they have engines. Engines have pistons and rods and valves, and they're constantly pushing and lifting and spinning at thousands of RPMs per minute. And the whole thing works great until there's no lubricant. And then everything seizes up, heats up, and breaks, and then you have to buy a new car. So lubrication is very important for the engines. It says here, for the average car, 15% of the fuel consumption is spent overcoming friction in the engine and transmission. That I had no idea. It was that large a percentage.
Yeah.
You think about getting the weight of the vehicle, just the physics of the vehicle moving, and then there's some wind resistance and getting it up to speed. But yeah,
it's just engine friction.
Just overcoming its internal combustion engine and its transmission takes up 15% of the fuel consumption. When friction is high, gears have to work harder to move. This means the car burns more fuel and emits more carbon dioxide into the atmosphere. Millions of tons of it just because of friction, says Jiang Huang, Associate Professor of Materials Science and Engineering at Northwestern University McCormick School of Engineering. About 5 years ago, Huang discovered crumpled graphene balls. This is a sort of novel type of graphene construction that resembles sort of like if you took a disclaimer and crumpled up a piece of paper and threw it across the room into the wastebasket. They do this by a capillary force generated by the evaporation of water crumbles the sheets into mineralized paper balls. All right, so made that discovery. Woohoo! I crumpled graphene into little balls. And he's explaining this to Yip-Hua Chung, another professor, material science and engineering, during lunch in Hong Kong, by crumpling up a napkin and sort of juggling, saying, "This is what I made, only it's really small and made out of graphene." And when the ball landed on the table and rolled, Chung recalled, it reminded me of ball bearings that roll between surfaces that reduce friction.
Ah, wow.
Bing, bing, aha!
Light bulb
Light bulbs
moment.
start going off. They say,
Yeah.
put down everything else we're working on and make this the focus of what we're doing now. So that's what they did. They put their crumpled up graphene balls into oils as lubricants. And they found the same number, 15% reduction. Well, not 15% reduction in the amount of wasted on overcoming internal combustion and transmission, but a 15% improvement on that, which would take that down by 1% or 1.5 or 2, right? So, but still,
every little bit helps.
Marked
right?
improvement. This is sort of interestingly, they sort of it doesn't matter. There's a certain point at which they've added enough that it doesn't. You can increase the concentration 10 times, but you get the same performance. So they have a certain amount. They've sort of narrowed down what that happy minimum is that they can add to get this efficiency. And yeah, off it goes. So future engines, we may have more efficient lubrication going on.
Lubricated with balls.
Yes.
Graphene ball.
Lubricating balls.
Well, it's also just really interesting.
Future of automobiles.
Because we think of graphene, you're supposed to think of graphene as like these sheets, right?
Mm-hmm.
Graphene sheets. It's just sheets. So the idea that he could turn them into balls and then come up with this idea.
Yeah, they dry tiny water droplets that have graphene-based sheets inside them.
Got it.
And as the water itself contracts through evaporation, it creates the crumpling.
Ha!
Or something along.
That's the right kind of crumple zone.
And yeah, there'll be
Speaking
yet
of
another
cars.
crumple zone in the car.
You like my car pun.
I do like
Yeah, that's good.
Oh boy. All right, you guys. Do you know what time it is? Well, do you?
It's been so long.
I'm not sure.
I forgot.
It's Blair's Animal Corner.
That's what it is. It's time for us to our company.
Smart creature, bright and small. Biped, millipede, no pet at all. Wanna hear about animals? She's your girl. Except for giant pandas and squirrels. Animal Corner.
What you got, Blair?
I have brains, Justin.
It's not Halloween, Blair.
Brains. But this is This Week in Science, where we have a neuroscientist on board. So I have some amazing things to talk to you about, Kiki. So first of all, this is less about brains. This is more about just cerebral inner workings. But we've talked on the show ad nauseum about the sense of direction in birds. Usually we've talked about it in pigeons, but we thought it was tiny hairs, we thought it was magnets, we thought it was all these different things. So most recently, we've kind of settled on this idea that it definitely has something to do with magnetic fields. Also recently, we found that birds definitely use landmarks. Well,
yeah, we've known that for a while. Yeah.
Right, but I think there was a study I reported on fairly recently where we kind of compared the two, and there's certain times that the magnetic field doesn't really matter, it's all about the landmark, and vice versa. And so in a most recent study with zebra finches, cue the sounds, no?
Cue the sounds?
Yes, your sounds.
Oh, right. I was busy being a neuroscientist and not the bird person.
Oh, okay.
Meep, meep.
There we go. I'm expecting that every time I say zebrafinch, and it makes my heart laugh. So I really appreciate that. All right, so
toy sound, yes.
So with the zebrafinches, they were checking out their what they call their magnetic compass in relation to polarized light. And what they found was that their magnetic compass is affected by the direction of polarization of light. So when the direction of the polarization of light is parallel to the magnetic field, they can use their magnetic compass. But when the polarized light is manipulated to be perpendicular, the birds get confused.
That's interesting.
Yes. And furthermore, looking at kind of their circadian rhythms, it looks like that also depends on the time of day. So when the current idea, and this is kind of the next step of the research, is that birds use the polarized light to accentuate the magnetic field during sunrise and sunset.
Right.
These are the times of day. Go ahead.
The polarized light is most visible.
Right. And so that's also the time of day when migratory birds, they kind of pick a route. They're like, I'm going that way.
Yeah, because a lot of birds fly at night.
Yeah. So either way, there's not a lot of flying going on in the in-between times. So sunrise, sunset, that's kind of when they have to calibrate themselves. But also, the other idea that the scientists have is that during the middle of the day, that's when they actually have trouble determining the magnetic field because polarized light is approximately perpendicular to the magnetic field. So that's also the time when landmarks are most visible. So that's also the time when they're going to need to stop and eat. That's also when they're going to have to keep an eye out for predators.
Yeah.
So using just their sense of sight, which most birds have amazing eyesight, they can do that during the day when the light is good. But then when they're starting their day, they're deciding their plan for the day, and also the light is not as good, or at sunset also, that's when they can use the magnetic field. So knowing that the polarized light has something to do with it, and knowing that polarized light fluctuates in its alignment with the magnetic field kind of leads the scientists to believe this. So it's an interesting extra wrinkle kind of in the navigation of birds.
Yeah, that is fascinating. I mean, I know that polarized light is important to many species. We don't know if it's all species, but many species who migrate, polarized light is important. So this kind of compounds why it's important. So for that, like you said, kind of just honing in on which direction they should be going. And then they're just interesting. There's all sorts of like at night, after the light goes away, if they're still flying in the middle of the night, then they can use like star compasses.
Right.
The birds actually fly using a star map as well. So that's the same as during the daytime, maybe using landmarks. So the visual cues that are available. And then the magnetic field being like the kind of final thing that keeps the birds going the right way.
Right. So the one caveat on this story that I feel like I have to do my due diligence here and put this little asterisk on the end is that this was only done with captive birds.
Right.
So we don't know how this actually relates to wild birds. This is not something we would expect would be that different.
And it was also done with zebra finches who don't really migrate.
Right. That's the other thing that's kind of weird.
Right.
So, yeah.
Not that they can't see the light or sense magnetic fields, but as far as I know, zebra finches are nomadic and not migratory. They follow food sources and water.
Yeah, so it's interesting. I just want to make sure. I know they used zebra finches, but it's possible they used other birds as well. No, it was just zebra finches trying to find food in a maze.
Yeah, so it's a nice model system, but they're not using a migratory species. They're not actually dealing with a bird during its migratory season.
It
we
was
would
it
actually
was
be
the it
having to.
was the plan. Actually, I know a little inside story in this research. It
Oh yeah.
was the plan. Unfortunately, the design team built too small of a maze, and and they couldn't fit the geese into
Right.
the maze, so they had
Uh-huh.
to switch at the last
Well, they
minute.
could have just used
Right.
pigeons.
They could have, yes.
Maybe that's next. Maybe
Yeah.
pigeons are next. Yeah,
I
so
don't know.
speaking of bird brains, let's go from bird brains now to mammal brains, and specifically carnivore brains. And I brought this story because I feel like it keeps coming up over and over again. When it comes to brains, is bigger better?
Yes, I will say yes. I
So,
will go with yes.
for example, in
Maybe.
humans, as far as we know, and correct me if I'm wrong, Kiki, but in terms of, the belief that, the pretty ancient belief that men had to be smarter than women because their brains were bigger, that's
Right.
been debunked.
Yes.
And
Right,
beyond
right.
that, just a general correlation between, at least in humans, brain size and smartness has not really been proven true at all.
Right. But if you take humans and compare us against other
Aha.
ape
And-
species,
Yes.
then we see a difference.
And
Right.
one more caveat to that, which is it's more important to have intact brain regions and areas.
Yes.
So
This is
so
a great
that's-
point.
Yeah, those areas being larger relative, or having a firm presence or not, a diminished presence can affect things greatly too.
Right. So
Right.
keeping all of that in mind, I just wanted to kind of
Because where else would you keep your brain?
that a recent study looking at carnivores, 140 animals from 39 different mammalian carnivore species, including polar bears, Arctic foxes, tigers, river otters, wolves, spotted hyenas, as well as binturongs, snow leopards, wolverines. They were given a problem-solving task. They were each given 30 minutes to try to get food from a closed metal box, and to access the food, they had to slide a bolt latch, which allowed a door to open, and they would bait the box with the favorite food of that study animal. For example, red pandas would get some bamboo, snow leopards would get some sort of meat. And what they found was that species with larger brains relative to body size, so this is the first part, larger brains relative to body size, and this is species-wide, were more successful than species with relatively smaller brains. So, for example, overall, 35% of animals were successful in solving the problem. Bears were most successful. They won about 70% of the trials.
Go Bears.
Meerkats and mongooses,
Go Bears.
on the other side of things, none of them were successful. And if you look at the body plan of a bear, they have a pretty massive head and they have a pretty massive brain cage. But meerkats and mongooses, they're very kind of tube-like. Their head's not that much really any wider than their body. And if you look at a meerkat skull, their brain case is not that big at all. So the correlation here is that, again, species, this isn't individuals within a species, but this is the species on the whole that had larger brains in relation to body size. So this isn't just the biggest brain, but the largest brain in relation to body size did the best in these problem-solving activities. Now, the interesting kind of next steps from this is that the researchers would like to look at this correlation and then in relation to social animals, because there's been a previous hypothesis that bigger brains came about as a result of needing to be more social, and that the social brain is the part that takes up all this space. So are social animals better at problem solving?
But meerkats are social,
Right.
and so are mongooses, right?
Also true.
Yeah.
So that is definitely interesting.
Yeah.
However, they also have a pretty extreme hierarchy. So I don't know, again, how they're defining social. So if you just have one meerkat in charge, one female matriarch, just like she is the head, and everyone else just stays out of her way.
All I know is I don't ever want to be in a cage when there's a hyena outside. I know that hyena is going to figure out how to unlock the door.
Yes.
That hyena will figure it out.
But because of, I guess because of hunters, there's no longer herds of bears roaming the western.
So that's the other thing. Bears are mostly solitary.
Yeah.
So right off the bat, the two examples that were in the article disprove that theory. So that's kind of where you have to look at it is, A, is there a correlation indeed with these large brains and social animals? Because mostly they've seen that in primates, I guess, is the larger the brain in primates, the more social they are. So then you have to ask about
wolves and orcas and all sorts of other big-brained, carnivorous, social group mammals. I mean, there's lots of examples, but then you got to, if you stop pointing them out, then leave out bears and lions and
right
and a lot of animals.
Go ahead, Kiki.
Oh, and I'm going to say, there's going to be a difference also between, say, carnivores and those animals that are herbivorous. So horses,
tiny brain,
rabbits. I bet rabbits would not figure it out. I bet
Look, I have a rabbit skull right here.
I bet rabbits wouldn't even try.
It's this much of the head is the brain. Look at that rabbit skull.
That's
so
wild.
For the listener who can't see what I'm doing, the rabbit skull is about 4 inches long, and less than an inch of it is for the brain case.
The hypothesis that has been put forward as to success and brain size as well in the bird literature is generalist versus specialist. So, so within the ecosystem, are you a generalist? Are you adaptable? Can you come up with new solutions to problems, or are you a specialist who has to have everything the exact right way all the time? And generalists are often are better at doing tests of memory, tests of skill. Tests of generalists are thought to survive better, basically. So I would say that I would say if you look at generalists versus specialists, as opposed to just sociality, because when you get into sociality, you have to start, I think, deciding what kind of social hierarchies, like you were saying.
Yeah, and then there's the whole question that Justin kind of alluded to at the beginning, which is, sure, your brain is bigger, but what areas of your brain is bigger?
Right.
That's really the question you have to ask, is what part of the brain is dealing with this? Is that part of the brain bigger?
And how's it wired? And I mean, like, how much connectivity between those parts of the brain? I mean, these are all...
They're very important questions.
You can have a very small, highly connected brain with lots of wrinkly stuff around the surface and outperform a bigger, less connected brain. It's just then the bigger brain is just for tissue storage or something because they have a big head.
Yeah, so it's an interesting conversation. Again, it's something that we keep bringing up, and at least with carnivores, a bigger brain is at least correlated to being able to solve this problem. So
correlated.
Yeah, correlative.
Correlation,
yes.
Not causation.
And then right before the break, I just have a quick story about zebra stripes. So I've talked a couple times on the show about zebra stripes, and for the most part, it looks like, the last time I talked about it, that the new theory is it's not for camouflage to get away from predators. It's to discourage pests, biting flies. They're less likely to hang out on something striped. So after that, the most recent study out of UC Davis and University of Calgary.
I don't like
UC Davis!
Yeah.
UC Davis!
We don't raise the roof anymore.
So, Justin, I suggest you go into the back catalog of TWIS and re-listen to that story about flies and striped
I
surfaces.
remember that story.
I don't remember it.
So, University of Calgary and UC Davis, they wanted to figure out exactly how these zebra stripes worked if they had something to do with camouflage, because whenever we've looked at it before, we've looked at it from a human eye perspective.
Mm-hmm.
And predators in the African savanna do not see the way we see. Their night vision is better than ours. Their distance vision, sometimes worse than ours, depending on the species.
They're often colorblind.
Yeah. So all of these things mean we have to look at this a little bit closer. So what they did is they did a series of calculations. They used math to figure out the distances at which lions and spotted hyenas, as well as other zebras, can see zebra stripes under daylight, twilight, or during a moonless night. So what they found was that at the point at which you could actually see the zebra stripes if you were a predator, you would be close enough to smell them.
Right, and so a big cat, would totally already know they were there.
Yeah, exactly.
Yeah.
So beyond 50 meters in, that's about 160 feet in daylight, or 30 meters, that's about 100 feet at twilight, they can be seen by humans, but they can't be seen by zebra predators. So again, only about 9 meters away on moonless nights, that's when they can see them. So they're so close, they're like right on top of them. They'd definitely be able to smell them.
But yeah, they could smell them much further away. I feel like they could smell them at the 50
that's the idea, is that they can smell way farther than they can see the stripes. So why would you even have the stripes?
How about it?
Because of the flies.
Well, but, I guess it's not to be camouflaged like completely off the radar. It's just like when you're running. Have you ever seen when somebody wears like vertical?
So that's called
and it starts going. It creates an optical effect.
That is called
like Kiki's got. It creates an optical effect. Maybe there's this optical illusion when a lion's bearing down. All of a sudden, it looks like one of those posters that you've got to stare through and into the background to sort of see the image in 3D. Is it? You know, nobody remembers those, but
I do.
Thank you. But maybe there's an optical illusion taking place that we will never know how trippy it is to stare at a zebra. And maybe that's why you ever see lions out on the savannah just staring at zebras, not even chasing them, just hanging out looking at them like, can you see it? No, I'm telling you, stare at that one long enough, you'll see an eagle. Yeah. Just keep looking. No, you got to look through it. You got to look past it, and it'll,
So can I talk now?
Sorry.
That's called cryptic camouflage. There's a term for that.
Oh my goodness.
And that's when you have a pattern that disrupts your body shape. Mm-hmm. And they tested that. And it turns out in treeless habitats that lions can see the outline of a striped zebra exactly the same as they could see similar sized prey with solid colored hides, such as other animals they eat, such as impala, right? So that was the idea of cryptic camouflage, that it breaks up the body plan. Hold on. The other thing that I have been teaching kids for over a decade, which is something that zoos talk about, is that the cryptic coloration could be a way for a herd of zebra to blend in together. And then you have this massive chunk of stripes, and a lion might not want to try and pick off a singular piece of this mob of stripes where they don't know where one.
It's one giant zebra.
So it looks like they did not look at all, and that's what I'd really want to see, is if it matters if it's one zebra or if it's 100 zebras, if that is enough to confuse them.
I'm surprised they haven't looked at that, because that seems like the logical answer. As a herd of zebras is moving, then you have these vertical lines. You can't tell if this is part of that zebra going this way or part of the other zebra going in the opposite direction. The only thing that drills back a little bit and makes me think, maybe it's not, and maybe it's just stripes, is that you would think that you would see this pattern perhaps appear in enough other prey animals on the
flocking animals that are prey animals that flock together, if that were the situation.
This could have been selected through millennia of hunting. And actually, who else has stripes? Tigers have stripes. They don't have stripes because
they're solitary. Yeah.
Right, so it's like, maybe stripes is just stripes, and we should stop.
However, there are lots of other herd animals that have stripes, even if they're more subtle, like kudu.
It's true. Or if they don't have...
Yeah,
and if they don't have stripes the way that zebras do, they'll maybe have black and white delineation along the rump, like white-tailed deer. So the tail goes up, and they've got the white tail, and then there's like the darker shadowing around the outside. So there's a change of shade, at least, between white and another color.
I still like the crypto, what you called it, with the herd. Making it hard to select.
Camouflage.
Yeah, making it hard to pick out prey in the herd.
And that's what I've been teaching kids at the zoo for years. And
teaching it. It's not gone.
So I say jury's still out on this, but we know that it doesn't, that they, by the time they could actually see the zebra stripes, they can already smell them, which I do think is a very interesting point. That takes away part of the previous hypothesis for the zebra stripes. And I do think that was a great methodology of how to figure that out, and a very good point. So
yep. But
we'll see.
Now they just have to look at them in groups, because you really don't find zebras standing all by themselves.
A lone zebra is a dead zebra.
Pretty much.
Speaking of zebras, I did bring this story because...
That's the other thing you teach the kids at the zoo?
Lone
zebra's a dead zebra. Stay with your friends. Nobody wander away from the group.
Actually, that could help at zoo camp. But, so this Sunday, if everyone consults their TWIS calendar...
Sunday.
International Zebra Day, is that right?
Yes. International Zebra Day. Look at that.
Go celebrate. Support your local zoo. Go see a zebra. Perhaps buy a TWIS calendar.
Oh, share your zebra stories. That's right.
Yes. Fill my Twitter inbox with zebras. Just send them my way.
That's what we want. TWIS, Blair's Animal Corner. We want zebras on Sunday. Lots and lots of zebras.
Be spammed by just so many zebras.
Oh, I wouldn't say that. Okay. All right, everybody. It is time for us to take a very short break. If you just got here, you are listening to This Week in Science, and we do hope you stick around for more great stories. I have more brain stories coming up in the second half. There's a lot more stuff coming. Stay tuned.
Explain the things you heard with more than intuition. The line of reason shows the way.
All right, everybody. We have 13 calendars left. That's it, 13 calendars. So please go to twis.org and get your calendar now, because supplies are really, really limited. There's only 13 left. That's it. Additionally, and I think that's including the 2 that are on my wall. That is. Additionally, we have a listener survey, an audience survey that we are taking. So if you would please go to twis.org and check out our audience survey. Help us out. Help us make decisions moving forward in 2016 about our programming and things that we do. And it's good to know why you listen to TWIS, why you watch TWIS, where, why, how, who, what, all the questions. We have the questions. Please give us the answers. We'd really appreciate it. Just head over to twis.org. The link is in it's one of the announcements on our webpage. Additionally, we have merchandise you might enjoy at our website. There's a Zazzle store, so click on the Zazzle link. It'll take you to our Zazzle store, and you'll be able to buy all sorts of shirts and hats and fun things like that with the TWIS logo all over it. It's fantastic. And if you are able to support us financially, we are supported by listeners like you. That's pretty much the way that it works. And your donations pay for our hosting, our bandwidth, contractors we need to hire. Everything that we do is supported by you. You keep this show going. So if you're able to give $2, $5, whatever you're able to give, it really helps. Every dollar, every cent helps pay all the bills and keep everything going so we can keep bringing this show to you. We have PayPal donation buttons on our website, so make it really easy by putting those on the main page and also on every show page. And we additionally have a Patreon account. We have some links on our website, but if you just want to go straight to Patreon, patreon.com/thisweekinscience, you can sign up to support us in an ongoing fashion, and we send you neat little swaggy things, fun things like pins and stickers and other stuff. That's a neat emblem to say thank you for supporting us. Whichever your preference for donating, please just go to twis.org because that's where you find all the links for doing that. So listen to the most recent show on the website, comment on the show, make a donation. We really appreciate it. If you can't afford a donation, we totally understand, but there are all sorts of ways that you can help out that don't involve money at all. If you listen to us on iTunes, give us a great review, glowing thumbs up, all that kind of stuff. If you like good reviews, go thumbs up the reviews that were really good and glowing for us. If you like us over, I don't know, tell people about us over on Reddit. I don't know. Make something up. Tell your social networks. Find ways to tell people about TWIS. It'll really help us out in the long run in a big, big way.
And the best way I've noticed, really, is just telling people.
Just telling people. We thank you for your support, and we could not do it without you.
I can't believe you believe in that plan. We disagree, but I still give a damn. Your astral projection.
And we're back with more This Week in Science.
You know it. Justin, what you got?
Oh, me again. Okay, this is skeletal remains of an 83-million-year-old dinosaur. Originally, they were found by a team of amateur fossil enthusiasts alongside a creek in Montgomery County, Alabama. They were found down in some marine sediment, and they said, well, I think we found something here, boys. So they called up, made some calls, some people looked at it, and they said, yes, this is really interesting. We must take a look at it. Now an international team of scientists have identified and named this as a new species of dinosaur that is the most complete and primitive duck-billed dinosaur ever to be discovered in the eastern United States, and therefore possibly pretty much the world. This duck-billed, oh no, I guess there's older, but still, this duck-billed dinosaur, it's also known as a hadrosaurid, if you can picture your hadrosaurids properly. It's probably 20.
That's a duck-billed dinosaur.
Yeah, duck-billed dinosaur. 20 to 30 feet long as an adult. Mostly walked on its hind legs, though it could come down on all fours to graze on plants. It had grinding teeth and a scaly exterior. Also, this particular one had a large crest on its nose. So it had the duck bill and a big thing coming down, like a big, funky-looking nose. This new discovery shows that duck-billed dinosaurs originated in the eastern United States, what was then broadly referred to as Appalachia, before dispersing to other parts of the world. Research team outlined their findings in the Journal of Vertebrate Paleontology. Hang on a second, I gotta... During the late Cretaceous period, roughly 85 million years ago, North America was divided in half, much as we are today, although then it wasn't along political lines. There was a 1,000-mile ocean that connected the Gulf of Mexico to the Arctic Ocean. I had no idea. This is the first I'm learning of this. The body of water created two North American land masses, Laramidia to the west and Appalachia to the east. The area which is now considered, which was considered Appalachia, is a bit wider than what we call it today. It began roughly in Georgia and Alabama and stretched all the way to Canada. Did either of you know about this? The two Americas? The 1,000-mile ocean? I had never heard of this before.
I might have heard about it.
Yeah, it might be deep in there somewhere, but it doesn't ring a bell.
I had no idea, right? For roughly 100 million years, the dinosaurs were not able to cross this barrier. The discovery of what they're calling Eotrachodon suggests that the duck-billed dinosaurs originated in Appalachia and dispersed to other parts of the world at some point after the seaway lowered, opening a land corridor to western North America. Its teeth show the dinosaurs' remarkable ability to grind up plants in a manner like cows and horses do today. They were able to consume a wide variety of plants as the group radiated around the world. The name, which I still can't say, Eotrachodon orientalis, means roughly dawn rough tooth from the east. So, very important find, showing the origin of a species of dinosaur as it spread about. But more importantly, most evident in this story is the fact that there were two North Americas.
You're like, oh, really? What? It looks as though there was,
Oh, you've got cool maps.
They're like islands, very large islands. Yes.
Yeah, so it looks like, yes, we knew about this.
Well,
people knew. I personally, it wasn't at front of mind.
I know that, I'm sure, based on the fact that they just told me so in this story, that this was a known thing. No, it was just my lack of knowledge that had never envisioned this ocean that stretched from the Gulf to the Arctic Sea. That's wild.
Pretty wild. Yeah.
Yeah, new duck-billed dinosaur from the east side.
Dinosaurs and the 76 million years ago, the climate was pretty different too.
Yeah, that's the other thing. Maybe this is also a projection.
Oh no.
Well, the electorate being what it is right there in the Heartland. Not such a bad.
All right. Kiki, what do you got?
I got some brain stories. So some very interesting, especially based on the commentary about bigger and better brains that we were discussing during the Animal Corner. Justin mentioned, areas of the brain being connected together and that connectivity being really important. Well, a group of European researchers published in the Journal of the Royal Society Interface took a bunch of volunteers and they put them in fMRI machines and then put them under drugs that made them lose consciousness. So they watched what happened to the activity in their brains as the people slipped out of consciousness. Yes, as they slipped from consciousness, they recorded what happened to brain activity. And so the fMRI was looking at, blood movement, blood use as a proxy for brain activity, thinking that, where the blood goes, the oxygen goes, the cells are active, and that's the proxy that we use. And so they pretty much determined that when people are awake, it's just networks. There's all sorts of parts of the brain, and they're just going, and they're shifting, and there is a flow of consciousness because there's all sorts of stuff around us that we're constantly picking up information about that we're not even aware of. And so there are various parts of our brain that are going into and out of activity and connectivity with the rest of our brain. And so it's just this constant fluctuating but very highly interconnected web of networks. And then as you slip out of consciousness, things become disconnected and they don't fluctuate as much. So it's very stable. It seems as though there's some kind of an underlying basic processing unit that kind of keeps everything going. There's the basic network, and that's just on when you're unconscious. But consciousness emerges as networks connect. Yeah, so researchers, they're trying to figure out if there's, if if we can understand consciousness, what conscious and unconscious is, then there might be better drugs to be developed for it. There could be better drugs for creating pain-free surgeries. There could be just understanding consciousness in itself is a huge, huge step. It'll be a huge step the day that we do understand it, if we ever do. I love, though, the question of these neural networks and the fact that these networks within the brain, that the more of them, these nodes pop up and then become connected to the network, and the more of them are connected, the consciousness appears. So it makes me think about things like, okay, our internet, the World Wide Web. It's connected, but it doesn't have multiple layers of networks connected in the way that the brain does. We have, say, potentially enough nodes in the World Wide Web, or enough people connected to the World Wide Web for something to happen, but it might be the manner of connection that's taking place. And so, because we have only basically one network that is the World Wide Web, that won't be conscious. But if there are multiple networks working in together, that maybe those together will lead to consciousness that we won't ever really know is there, because we would be just like the neurons, right? Not aware of our consciousness, but part of the consciousness.
Whoa,
So
man.
here's a story that combines this with Blair's brain size story. That just popped up on my radar. This is a new theory linking brain activity to brain shape.
That's interesting.
UNSW Australia scientists have shown that complex human brain activity is governed by this same simple universal rule of nature that can explain other phenomena, such as the beautiful sound of a finely crafted violin or the spots on a leopard. They identified a link between the distinctive patterns of brain function that occur at rest and the physical structure of people's brains. So, yeah, they used a couple of techniques. They got the MRI, and they got another technique. What is the one that they're using here? They used a diffusion tensor imaging to build three-dimensional maps of the structure of the brain of 10 people. 10 people, tiny, tiny, tiny sample, right?
Yeah.
The MRI gives us the structure of the cortex, the wrinkly surface of the brain, and the DTI gave us an anatomical map of the underlying connections of the white matter in the brain. The team then analyzed these brain maps using mathematical framework of Laplace eigenmodes, or harmonic waves, which describe natural vibrations of a system where all parts move together at the same frequency. Our results show the shape of the brain matters in the same way that the precise wooden shape of a Stradivarius violin matters if you want to produce an exquisite sound when the strings are vibrated. Brain activity resonates with the precise anatomical structures of the brain to produce the resting networks of oscillations that we observe. So these are all just resting observations, not activities. But patterns we predict with the harmonic waves on the human brain can be compared to the musical notes composing a complex musical piece, the building blocks of more complex patterns of brain activity. Yeah. Interestingly,
cool. Because we do know that that the frequency of the neuronal oscillations affects the way the brain works. But now, because of it, but that's just looking at the electrochemical frequency oscillations. But now we're talking about the shape of the brain actually affecting how those electrical oscillations have harmonics and bounce off each other. And
so
wow.
so it could be also, if you get a larger brain,
we're all just vibrations, man.
Harmonics become all off. It's now
Right.
You're playing a tuba instead of the trumpet, and you can't do higher human think function stuff anymore. I don't know. But it's as they say, interestingly, this is Associate Professor Pearson involved with the study apparently, and interestingly, same kinds of harmonic waves are thought to explain other self-organizing phenomena in nature, such as the patterns that sand forms when sitting on a vibrating metal plate, or the development of biological patterns, such as the stripes on tigers and spots on leopards. So maybe
Cool.
it's just a big accident of the human brain getting ish to the... no, that's too much of
No.
ignoring all of human history.
Yeah.
But still,
No.
for the higher functioning stuff that we do now that we didn't before, maybe we're just in the right groove right here.
Yeah, I mean, maybe it's the fact that we're upright and that led to our head being shaped a certain way, which our brain has to fit inside of the skull and has to be a certain shape to do that. You know, we don't have long, elongated heads that allow the brain to spread out. You know, yeah, possibly, but we don't know. This is a very interesting idea.
Interesting look.
It's all just frequencies and vibrations, man.
All it ever was.
But not really. Kind of not really. So a study in Nature that's really a big study, and I say big because it's huge. Like, they genetically analyzed around 65,000 people. They actually took blood and took samples from over 100,000 people, but then did genetic analysis on 65,000 people. This is really a huge effort. And researchers were trying to find out if there's anything. Is there a gene? Was there 1, 2, 3 genes that could explain prevalence of schizophrenia? And they found one. They found one. So it's a gene called complement component 4, otherwise known as C4, and it's known in the immune system. People have studied it for a long time, and it tends to be involved in marking microbes for destruction, and that's kind of its job. Well, it's also, researchers were like, oh, let's take a look at it and find out what it does in the brain as opposed to just the immune system. And they found out that it is incredibly important during the period of development in which synaptic pruning takes place. So C4, very important for allowing the brain to prune properly. It attaches and helps another complement protein called C3 connect to neurons and mark them for pruning. And so if you have too much of it, you get, in one direction or the other, you either get too much pruning or too little pruning, which can affect the brain negatively. And in the case of, say, too much pruning, you get schizophrenia or schizophrenic-like symptoms. And this image is just, it blows my mind how striking this gene on this chromosome was. They showed the sites in they showed all these sites that they were looking at, these risk associated areas in the kind of schizophrenic genome.
Spectrum.
Yeah, in the spectrum. So all these individuals, okay, which one of them have risk factors for schizophrenia, which have schizophrenia out of these 65,000 people, what are the genes that are linked to it? So we know who the people are, we know whether or not they have it or don't, and now we can start making this map. And so this C4 gene is like, I don't know, what is it, like the tallest ones kind of average around this significance of about 15 to 17, and then all of a sudden C4 is like over 30. It doubles the risk. This one particular gene is like the gene that is incredibly important to schizophrenic development.
But spectrum again. So what's sort of interesting then, if you look at that and you were just saying like percentage-wise, this, that, the other, risk factor, that might be and I'd have to see if they're correlated, so that if you have this one, you likely have these other 3. But if it's like you just have one and that's enough, then you may be on that verge of being able to start to make distinctions between ways in which schizophrenia can be defined, because it is a spectrum.
Right.
We know it's a bunch of diseases. It's not one disease that's taking place or one thing that's being affected, even though it can have similar symptoms. So
Yeah.
that's a great drill down, though. I mean, that's
Yeah.
and that's one that they didn't suspect. This is a gene they didn't think
Mhm.
had anything to do with. This is an immune gene. This isn't something
Yeah.
that they thought
It's supposed to be in the immune. It works in the immune system. What does it do
Right.
in the brain? Oh, it's for synaptic pruning. Oh, that's a big deal.
See.
Okay. Yeah. So that's pretty. Yeah.
And the fact that, I guess, in synaptic pruning, it's probably not pruning very much, I would assume. I would assume it's not an over pruner, but an under pruner with this affect.
Yeah, so the amount or the variation in the protein itself determines the amount of activity that it does. So how much it interacts with RNA to create the C4 gene, and the way that it works is that, let's see, where did I find?
And I'm just saying that because I would assume excessive pruning would be more of dulling of the senses, whereas not pruning would, I think, lead to more extravagant experiences and interactions that you would think would be associated with the.
Right. So the way this seems to work is the more C4 you have, the more activity of C4 an animal has during this crucial time of development, the more synapses are eliminated. So the more you have, the more pruning. It's like the more clippers you have.
So it's
available.
the opposite of what I thought. There's more clipping going on.
More clipping with more C4.
Interesting.
Yeah. Yep. Tooth sweaters?
Two words that in no way have ever
You got
been
your teeth in
combined.
my sweater. You got your sweater in my teeth.
Sweater made
It's
out of
actually
teeth.
horrifying.
Or a sweater for my teeth. I'm not sure which way to visualize this.
They're really pretty sweaters. They're really, really pretty sweaters.
But are they sweaters that go on your teeth when it's cold? Or is it a sweater made out of teeth?
No, you know that feeling when you don't brush your teeth for several days and you're like,
it's tartar.
My teeth are fuzzy.
Oh,
Tartar.
Tooth
Normal.
sweaters. Not normal. So researchers publishing in the Proceedings of the National Academy of Sciences had people not brush their teeth for an extended period of time, and
What's
then
an extended period of time?
I believe it was like 24 to 48 hours.
That's an extended period of time?
12 to 48 hours without brushing teeth.
What are you
Gross.
talking? Who's like brushing their teeth every 12 hours? Like an OCD tooth person.
I try
There's
to
no
twice a day at least.
There's no need for this nonsense.
Well,
People are
these researchers, they used toothpicks to pick, the stuff that had grown on the teeth, off of the teeth. And they tried to do it really carefully so that they could preserve the growth of the bacteria that had been growing on the teeth, making these beautiful sweaters. And so they grew the bacteria, and then they imaged them. And they're beautiful. And they show that the bacteria in our mouths actually grow as a community, and they depend on each other.
Mm-hmm.
So what we see, it looks as though it's kind of like a layered structure where there's a thick bottom layer and then thinner layers that grow up above it, each of them growing on top of each other. And then there's some long tendrils that will grow from, say, a top layer down into a lower layer.
Top leather is something completely different.
Completely different. And what they discovered is that, it's a population. It's a community. These bacteria...
All you homicidal
It takes a village.
brushers and mouth rinsers.
Yeah, you can't just,
taking out communities.
You're taking out communities, yes. The researchers collected, they tagged the genuses, and so we have Cornybacterium, Streptococcus, Porphyromonas, Haemophilus, Aggregatibacter, Neisseria, Fusobacterium, Leptotrichia, Capnocytophaga, and Actinomyces, all
These might as well
living.
be soccer teams in
Well,
Europe, like
yeah, well,
minor league soccer teams, for all I
each
know.
right, but each genus kind of does a different thing. They have a different role in an environment, right? So what they found is that the layered structure that they found is all these different bacteria structurally developing their community in a very specific way. So what we have is a base layer, and the base layer kind of it grows. It's the base. It grows everything in the base, and those seem to be the Corynebacterium. And then you have kind of an annulus ring outside of the base layer, and those are more anoxic bacteria, which means they don't need oxygen. And so in there we see the Leptotrichia, you see the Fusobacterium, you see the Capnocytophaga, and then you have the perimeter species that are out on the edge, and those have carbon dioxide, lactate, acetate, and hydrogen peroxide metabolism. And so those bacteria are Streptococcus, those are the Haemophilus, those are Neisseria. These different bacteria exist in different places, and they can't exist in any other. And so if you remove, say, the acetate, the bacteria that metabolize acetate, then that's going to mess up the whole population, because taking the acetate or out of the picture helps the other bacteria. So if you take an acetate metabolizing bacterium out, you have to put another acetate metabolizing bacteria back in.
So is there a chance that these bacteria have evolved this community in the human mouth over millions, if not billions of years? Well, millions of years in humans, but is there a chance they're beneficial?
Absolutely. So the question is, which ones are beneficial and which ones are not? There are two different structures of these growth mats, these bacterial mats on your teeth that they found. And so they have a hedgehog structure and a corncob structure. And so these
farmers.
Yeah, the corncob structures are long, stringy structures where you have a base filament and then another bacterium that grows at the tips of the filaments. So it does kind of look like, I don't know, it looks corny. Mm-hmm. Yeah, and then the other are hedgehog structures, and the hedgehog structures are more of the layered structure, and they seem to be this like fuzzy mat that are really pretty, and they have a lot of a lot of density to them. So we've got corn cobs at the edges, and then hedgehogs in the middle.
Protective layer, if you will.
Protective layers, yeah. But we don't know which ones are good or bad, healthy or not healthy, or how they affect human health at this point in time. What my guess would be is that it all depends on which bacteria are in the populations growing on your teeth. If you
you want to brush like kind of hard, but not too hard.
No,
right?
no.
No, you want to stop brushing. This is the point of the story. Listen up, Blair.
That's not what I'm saying. Either of you, you're both so wrong. You're both so wrong. Oh my gosh. Well, we do know that the good, healthy population of bacteria in our mouths is beneficial to health, or at least not detrimental to health. The minute you start getting an imbalance of the bacterial population makeup, that's when you start getting things like gingivitis, gum disease, that can lead to further health problems because it opens up your gums to allowing bad bacteria to get into your system to maybe affect your heart. So don't brush too hard because you can hurt your gums, and that's bad.
I asked my dentist.
Don't hurt your gums.
After saying that, he pointed out that I had the early onset of gingivitis at my age, which isn't a bad thing, I guess, at this point. But I was like, well, have you ever had a patient who didn't have some level of gingivitis taking place? I mean,
Just because of the act of brushing teeth?
well, I mean, at what point is it a disease and not just gums recede over years? Like, at what point is it actually, like, it's kind of like, that's like everybody has this, right? Like, it's not a disease if everybody's got it. It's just gums receding as you age at that point.
It's a fair point. I've wondered about that as well.
And he paused. No, I gotta pause. I gotta pause. Like,
He's like,
it's fine. It's a disease everybody has. It's a disease everybody
buy a
has.
soft toothbrush.
Soft toothbrush, right?
You want your teeth or not? Yeah, okay, I guess I do.
Exactly. And some people, and it depends, and so there are all these questions because some people are more prone to plaque buildup and gingivitis and things that are detrimental eventually to your teeth and your health, and more so than other people. And we don't know exactly why, but it probably has to do with the bacterial populations that exist in your mouth from the time that you're very, very young. So
if you are one of these people who hasn't had cavity problems, you should probably lay off the brushing, the everyday thing. You should lay off the everyday. You probably have a good microflora, and you don't want to wipe them out. I mean, you don't at least want to brush real thoroughly.
You don't
want
listen
to
to
floss
that, Justin.
every tooth, and you don't want to like mouthwash with something to.
Disclaimer. Yeah, mouthwash. I will agree. Stuff that is, unless a professional,
especially if a dentist has said you don't have any cavities, but I'm going to have you start using a mouthwash, then definitely don't do it.
All right, what else we got?
All right. So
but it's like, move on to something I can agree with. I hate everything about this conversation.
I just want everyone to have fresh breath, okay? Can we just move on?
Yeah, you can eat candied mints. Those will both feed your mouth bacteria and allow you to have fresh breath.
This is not a medical show.
Are we in the quick rundown?
We are in the very quick end of the part of
I've got one quick one here.
We are in the quick and the end of the part of the go.
Is, Bill Nye, the sciencey guy.
The science guy, yeah.
The sciencey guy. He has flipped. He's flip-flopped on his GMO. He's finally come over to the Justin position that we need genetically modified foods to keep people from starving and to say that they're a good thing. He has been, even though he's been on board with the global warming and the everything else that science does and supports science, he's remained a sort of fringe skeptic of the GMO food thing, and has even spoken a little bit against it, and in that he doesn't understand why it makes sense to modify an organism, put it out into nature, and this is something that needs hesitation and pause and trepidation. Reversed, he was researching for a book he was writing where he was expecting to focus in on those things that he was being skeptical about, and after talking to lots and lots of scientists, has changed his mind, and now says, well, here's a quote. I went to Monsanto, I spent a lot of time with the scientists there, and I've revised my outlook. I'm very excited about telling the world. When you're in love, you want to tell the world. So he's finally come over to the Justin side of this issue. Welcome. Bill Nye, there's always been room at this table for you, actually.
I want to mention, too, that Gordon McLeod in the chat room is making a really good point, and he says, I object to the use of the term flip-flopped. He did the sciencey thing, and he adapted his point of view in light of new evidence. And
I object to flip-flop being used in the negative or thought as a negative connotation.
Well, but it is. You can't get around that.
Because that is a good thing to be able to do.
So instead of
change your opinion is fantastic.
Yeah, you can say that he reassessed his opinion in light of new evidence.
No, I can say he flipped his opinion on the flap of more information.
That's fine. Speaking of flip-flopping, terrible segue.
Okay.
Well, God, what is this story?
No, so there's a type of lizard called a tegu, T-E-G-U.
Bless you.
Everyone should Google it. They're adorable. Anyway, they're from Argentina, the black and white tegu, and they've been discovered
Gesundheit.
doing something that that reptiles aren't supposed to do. So reptiles are cold-blooded. That means they're the temperature inside that it is outside. They cannot create their own body heat. Well, these guys can raise their body temperature 4 to 10 degrees Celsius in the months of the mating season from September to December. And the scientists even withheld things like extra food, and they kept them from being able to be out in the sun, and their temperature still went up. So something is going on internally that is causing this. Whether it's the fact that their heart is beating faster during this time, maybe they are actually metabolizing heat or metabolizing food or some sort of energy and making heat, or it's possible it's hormone related. There's a million other potential possibilities here, but the bottom line is a cold-blooded animal is making their own body heat selectively just during mating season, both males and females, and if we can figure out how they're doing that, that might be a really good clue as to how animals first became warm-blooded.
I think it must be love.
Yep, you got it. Never mind. Solved it.
They're completely warmed up by love.
Call off the scientists, put down your pipettes. We got it. Everyone can go home and see their kids.
That's
it's
right.
love.
It's
Oh.
love.
Yep.
Oh my goodness. My last two stories. Blue Origin, the spacecraft company, they have successfully flown their reusable booster rocket, the New Horizon. Is that what it's called? The New Shepard, the New Shepard rocket, and successfully landed it vertically again. So that's twice now that they have gone, let's launch a rocket, and it worked and it didn't blow up, and then they said, let's land the rocket, and it landed and it didn't blow up 2 times now. Come on, SpaceX, pull it together. And then fertile faces, the world round. It turns out there's a question as to whether or not human women, are able to tell when other women are ovulating or in their fertile period. So researchers published a study in the Royal Society Journal, Biology Letters, and they had women look at pictures of other women and try and pick out the fertile ones. I mean, basically, they had the women look at the pictures, and they had to choose the most attractive faces. So they saw these pictures and had to choose the more attractive one, and then they were asked which woman would be more likely to steal their own date. So picture yourself on a date with your significant other, and now look at this picture. Pick the more attractive woman and figure out which one's going to try and steal your man. Anyway, the researchers came up with some really interesting results. They found that naturally cycling women with higher estrogen levels, estradiol levels, were more likely, so these are women who are not in their fertile phase, so naturally cycling women who are doing the choosing, not in their fertile phase, were more likely to choose the ovulatory woman as the one who would steal their date than ones with lower estradiol levels. So, yeah, and this is not involving the scent of smell. It's not involving any senses other than just no pheromones. It's just pictures and a hypothetical situation.
Right. Yeah. There's a lot of weirdness going on with this study. One of them is the sample size is pretty small. I am concerned about their methods. It doesn't sound double-blind to me. There's lots of things about it that just don't seem super science-y.
Yeah, also you can't see the women's ankles in the picture, which I've always thought was the clearest of indications.
All right. But the other thing is that
I'm agreeing. It could be very subjective to who they chose to be.
I've always thought too that it would be much more likely, this is my own personal hypothesis, that if, I had grant money and the capability to do this study, this is a study I've always wanted to do, which is, I think it'd be interesting if men were more attracted to women when they are menstruating, and the reason I would think that is because we don't have a great sniffer. But that is probably the time when fertile women are putting off the most kind of pheromones of what's going on, and so you know that that woman is capable of getting pregnant.
Yeah. So the double blind, that's where maybe, but the
This
double
is something
blind
I've always wanted to do.
double blind in this study would have been to have a different group look at that same group of women in different points in their cycle, or the women look at those. Yeah, that the women in the pictures needed to have two sets of photos, and you would have separated that and had the same women or different women, I guess, look at the two sets of photos of the same women in the sample. And if their point in the cycle was different, you would see different upticks in who was the threat to the date. And because I don't think they did that, because I didn't read it, but I'm assuming they didn't take all that effort.
So no, they actually went through some really interesting effort, though.
Okay, so give me.
So let me give you. So they composited images of women. So they took 18 women that had their pictures taken during ovulation, and they composited all of their images together to create the image of a woman ovulating. So on the left, there's a composite and another composite. And then they had another, which is in the luteal phase, or non-ovulatory phase of the menstrual cycle. And so these images look very similar, but they are these composite images, and they made 40 pairs. 40 pairs of faces, ovulatory and non-ovulatory, that were shown to the women based on composites. Anyway.
That's pretty fascinating. So that leads more credence to the result than.
I think more study is needed.
Yeah, I just think it's interesting that, they were created these images, and then they also had the hormonal information on the women they were testing and asking to make the choices. So I definitely think more study is needed. This is an interesting early result. I mean, it is a small sample set. With this particular part, there were only 60 individuals who were ever asked these questions. So 60 is not very.
And again, very rarely do we say, no more study needed.
Fair point.
That's right. Fair enough.
Very, very rare.
But what was the percentage that they actually picked out the woman that was ovulating? It was a pretty small percentage.
Right. Let's see, the percentage that they actually. La 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 la. Let's see if I can actually find a number for you.
Let's see if with more information I flip-flop my opinion on how.
Oh boy.
Interesting this story is. I'll give you this. If it's only within 10% of the mean, I'll just say it's a non-result. I would need more than 10%. I would need it to be like 60-40 or 61-39 to be like, that's a pretty significant hit.
Yeah, I don't know the numbers offhand.
Yeah.
I wasn't ready for that question.
Yeah, sorry. I'll look into it a little bit more, but it's also, I think it's difficult to ask them who's likely to steal your data away from you. I feel like they're skipping several steps. I feel like first you just need to know if women can pick out a difference at all.
Right, if they can pick out any difference.
Yeah.
Mm-hmm.
It's
And
because then taking the jump from they can tell if a woman's ovulating to they can tell if a woman's ovulating and they see them as a threat. Those are two distinct steps in the study from what I see.
yeah, and it's good that it's subtle and it's not something that we just obviously recognize in society. It's like, so how's your ovulation going? Obviously you're ovulating. Would you like to have a child right now? Because I have this friend who's been like talking about he wants to have kids. I'm just saying because you're ovulating.
Yeah.
Like it would be
So-
really awkward if it was that like.
So the results here say that the majority. So the way it works when they pooled, they had like 160 individuals for the overall study, and all of the individuals, out of all of them, there was no difference in choosing the ovulatory face over the other face. So there's no difference. There's no when all the data was pooled, there was no likelihood that a woman would find an ovulatory face more attractive, or that they would suspect a version to be more likely to entice their date away from them. However, when they dug down into the data, only considering women with high estradiol levels, that's when they saw that women were more likely to choose the ovulatory face as the ones that would entice away their date. And this is they have a p-value of 0.008.
Not big enough.
Which is a decent p-value.
No, that's a good p-value, but again, with such a
But
small
it's a small sample size.
if you only have
It's a
60
subset.
women and only 20 of them are ovulating, then to get a p-value like that, you don't need that many women to actually have a positive.
It looks as though with the t-test, that they may have had 14 women.
Yeah.
So
that's not.
yeah, it just, the numbers get smaller and smaller and smaller.
Yeah. It's kind of.
Yeah, but there's the question is there: when and how do women determine their competitors?
And I am 100% convinced that there are all sorts of hormonal cues going on between people of the same sex and people of the opposite sex. There's an intense subconscious conversation going on between our biological communities and everything. We've talked before about how your biome influences your attractiveness and things like that. So it's all going on. But whether I can look at somebody's face and tell if they're ovulating and then on top of that not be happy about it, that's the part where you totally lose me.
Totes.
But
I hope
I'm
we haven't.
attracted to you, but I have no understanding of why. You must have bacteria that I haven't experienced, or my bacteria are attracted to your bacteria.
You
Because obviously
smell like
everything
you have
you've
a
said-
great microbiome.
Everything you've said is a turnoff thus far. Intellectually, you're not stimulating me at all, but I'm very attracted to you for some reason. It must just be my bacteria, like your bacteria. So.
And right now is that time when I hope that our listeners are still attracted to us. But it is a time for us to end our show.
Oh, we gotta go. And you know
go.
what? We did this was supposed to be, February was supposed to be the hard hour.
Yeah. Mm-hmm.
This is the hard hour month. And we started
it's
a half hour
January.
late.
It's
and
not
we're gonna
February.
have an hour and a half for the show.
Justin, stop.
Oh, no, that's next month. No, that's next week. Oh, you're right. Oh, I'm early. It's because it's a leap year. I'm all off.
Okay. Take it away, Kiki.
I would like to take this opportunity to thank our Patreon sponsors. Thank you to Kevin Parachan, John Ratnaswamy, Steve DeBell, Patrick O'Keefe, Jason Schneiderman, Rudy Garcia, Gerald Sorrells, Greg Guthman, Dave Neighbor, Jason Dozier, Matthew Litwin, Eric Knapp, Jason Roberts, Patrick Cohn, Lord Tritonian Moody, Richard Onimus, KDWB, Byron Lee, EO, Bob Calder, Jared Lysette, Brian Ulysses Adkins, Brian Condren, Jake Jones, Trainer 84, Kati Volk, Edvardus Rumkus, Brian Hedrick, Cassie Lester, Sarah Chavez, Stephen Stroyak, Layla, Shannon Tara Ginsburg, Marshall Clark, Charlene Davidson Henry, Don Kamarechka, Larry Garcia, Randy Mazuka, Ed Dyer, Tony Steele, Dave Friedel, Craig Landon, Daryl Lambert, David Wiley, Robert Aston, Andrew Dolinger, Sylvan Westby, Artyom, Michael Perez, Shuwada, Stephen B., Dave Wilkinson, Steve Mashinsky, Rodney Lewis, Braxton Howard, Phil Nadeau, Rick Ramus, Salgood Sam, Matt Sutter, Emma Grenier, Philip Shane, James Dobson, Kurt Larson, Stefan Insom, Michael George, Russell Jensen, Mountain Sloth, Jim Drapeau, Tara Payne, Alex Wilson, John H. Maloney, Jason Olds, James Snow Wiles, Paul West, Alec Doty, Iluma Lama, Joe Wheeler, Dougal Campbell, Craig Porter, Adam Mishkan, Aaron Luthen, Marjorie, Paul Stanton, Scott Lajewski, David Simmerly, Tyler Harrison, Ben Rothig, Columbo Ahmed, and Gary Swinsberg. Thank you so much for all your support on Patreon, and if you're interested in supporting us, you can find more information at patreon.com/thisweekinscience. Also remember that you can help us out just by telling your friends about TWIS. And on next week's show, we'll be back once again with more science online, broadcasting live at 8 p.m. Pacific time at twis.org/live. You can watch us and join our chat room there. But don't worry if you can't make it. You can find our past episodes at twis.org/YouTube or just twis.org.
Thank you for enjoying the show. TWIS is, of course, available still as a podcast. Just Google This Week in Science in your iTunes directory, or if you have one of those mobile-type devices, you can look for TWIS, the number 4 Droid app in the Android marketplace, or simply This Week in Science in anything Apple marketplacey.
For more information on anything you've heard here today, show notes will be available on our website. That's www.twis.org, where you can also make comments and start conversations with the hosts as well as other listeners.
Yeah, there's lots of other listeners. But if you don't want to talk to them, you can talk to us directly. Email Kirsten at thisweekinscience.com, Justin at twistminion@gmail.com, or Blair at blairbaz@twis.org. Just be sure to put TWIS, TWIS, somewhere in the subject line, or your email will be spam filtered into oblivion. You can also hit us up on the Twitter, where we are at TWIS Science, at Dr. Kiki, at Jacksonfly, and at Blair's Menagerie. We love your feedback. If there's a topic you would like us to cover or address, a suggestion for an interview, please let us know.
We'll be back here next week, and we hope you'll join us again for more great science news.
And if you've learned anything from tonight's show, remember...
It's all in your head.
This week in science. This week in science. This week in science. This week in science, it's the end of the world. So I'm setting up shop, got my banner unfurled. It says the scientist is in, I'm gonna sell my advice. Show them how to stop the robots with a simple device. I'll reverse global warming with a wave of my hand. And all it'll cost you is a couple of grand. 'Cause this week's science is coming your way. So everybody listen to what I say. I use the scientific method for all that it's worth, and I'll broadcast my opinion all over the earth. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got one disclaimer, and it shouldn't be news, that what I say may not represent your views, but I've done the calculations and I've got a plan. If you listen to the science, you may just better understand that we're not trying to threaten your philosophy. We're just trying to save the world from jeopardy. Jeopardy. And This Week in Science is coming your way. So everybody listen to everything we say. And if you use our method instead of rolling a die, we may rid the world of toxoplasma gondii. 'Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 I've got a laundry list of items I want to address, from stopping global hunger to dredging Loch Ness. I'm trying to promote more rational thought, and I'll try to answer any question you've got. So how can I ever see the changes I seek when I can only set up shop 1 hour a week?
This Week in Science is coming your way. You better just listen to what we say. And if you learned anything from the words that we've said, then please just remember it's all in your head. Cause it's This Week in Science. This Week in Science. This Week in Science. 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 This Week in Science. This Week in Science. This Week in Science. 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 This Week in 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 Science.
The show is too late. The show has gone on too long. I'm so tired. We started late.
Is
We did a
bedtime?
long show. I'm tired. I'm so tired.
Is bed- Time for bed?
It's bedtime. It's time. Tired. Kiki. I was just looking at the video. Who posted that? It's really pretty. Strengths posted a video of a paraglider paragliding with the aurora borealis. It's really pretty. Very pretty. Cool. So, after showing, I just asked if anyone could pick their favorite episodes from 2015. There is a, why, applying to something, says Blair? Yeah. Oh, there's a, I'll put the link in here if I can find it. I posted it a couple days ago. The National Academy of Sciences is doing a Science Communications Award, and it would be pretty awesome to get nominated and get awarded. So I can put the link, and we can pick a whole bunch of episodes here among us, and then everybody could go nominate us.
Do we have to pick one episode? Is that the deal?
No, there's like 6 episodes.
Okay, so episode 500 is great.
6, yeah.
But I bet we did a really good interview at some point too.
Yeah, I think
NSF.
a couple of good interview shows there are in there, and I think that would be good. So the episode 500. I think also our end of year show, the wrap up show, was pretty good. I always think we do a good show on that one. And then, the Bones Cave Discovery. That was a good show. Yeah, Whiskey, maybe that would be a good one too.
Wait, I missed something. We're looking for some sort of best of?
Good
show?
No, not best of. No, just favorite episodes from 2015. I need 6-ish.
Oh, 2000. Wait, when?
Just last year. Favorite episodes from last year.
Yeah, I think the Bones Cave Discovery one was the Homo naledi, right?
Yeah.
That's a good episode. Yeah. Yeah, I agree with you though. I think they were all good. I don't know that we took a show off completely last year.
We had was it last year that we had our lost episode? It's gone. It's just the one episode that's I think it was episode like 515 or something. It just disappeared.
Oh, man.
It's gone.
Yeah, I think I had a good disclaimer that week too.
Yeah.
Didn't I? I think I have one.
It was a great show. We did a great show, just nobody saw it. Which is pretty funny.
Yeah.
Yeah.
What a bummer.
Was there a Waters of Mars interview?
We had the chief engineer from Curiosity.
Yeah, was that last year though? Was that before I moved?
Of course that was last year. It wasn't this year, was it? Was it already? No, it was last year.
Or I just wondered if it was 2014.
No. This was just last year.
No, it would have been the Curiosity one was 2014.
Wait. No. It was after the whole thing had gone. We got results and everything. We didn't get the interview until like there was a book out or something. I don't know. It was like the dust had settled.
Oh, how about the octopus show
I was gonna mention that one. I
Okay.
thought that one was really good.
with Dr. Richard Ross? That was
Yeah.
fun.
Yeah, he's
Okay.
fun.
Yeah, I thought it was February a minute ago.
Oh yeah, the one with the guy who was applying to go on Mars 1. That was very interesting.
Yeah.
Oh
that was
yeah,
fun.
with
That was a good
Chris.
show. Yeah, it's amazing. We remember all the interview shows. I don't remember anything I talked about.
I only have 2 interviews last year. That's not right.
No.
Oh, let's see. We had an interview last April about Atlas and LHC with Zach Marshall.
Mhm.
That was a good one. We had a show with Scott Lewis where we talked about Hubble and stuff.
Only one?
We should have another show with him again.
Yeah, he's a good regular.
He's a good one.
And
the
we had
Chicks in
the
Space interview.
Oh yeah, that was fun.
Chicks in Space. We had the. I'm still waiting for my home editing kit, by the way.
I don't think those come out until the spring this year.
What about? Do we want to throw in a short in there too?
Yeah, we could do. Yeah, did we do one in 2015?
I'm trying to remember. So
Do any?
I thought maybe we did an interview. Oh, yeah, we did a short as a we did an interview about the sea stars.
Oh, interviews.
Sea
that's
star
right.
wasting disease.
What did I
We
do?
did that. Maybe that's the only short we did last year.
Oh, we put up
Remind me
Twist
this.
Manhattan short.
Remind me
And
this
then
week.
there's didn't we put up the
The
sharks?
sea stars.
Oh, the
What
New
was
York.
that in
Yeah, the New York
2014?
show last year. Where's that?
Yeah, the video's not very good though, Justin.
Oh, but we have the documentary.
We have the
Yeah.
we have the Twist Takes Manhattan
But-
documentary.
But there's no science in that really, is there?
No, but I still like it. We remind me, Kiki. You have to remind me this week because I don't have the information handy. I have it though. The mouse lab people.
Oh yes, yeah.
I
We should
wanna
do that.
talk
I would
about
love that. Yes.
Yeah. That would be a fun one.
Yeah, audio identity for saying I don't even have an audio file for 515. Exactly. It is the lost episode. It just doesn't. We did it, and it doesn't exist.
We didn't even have live viewers. We just did it without anybody.
We thought people were watching, and nobody was really able to get it.
And we figured it out partway through the show.
Yeah, the Emily Lakdawalla show was great. When was she on? Why didn't that show up as an interview, one of the interview ones? That should have shown up there, because that was a good one.
Is that the basketball bouncing one?
Oh, that was another good one. Yeah, that was
Science
another
girl.
good one. Yeah, Science Girl. Physics Girl.
Physics girl.
Yeah.
Science girl is somebody else. It's kind of a tragic tale.
I didn't. Oh, I didn't say interview. I just said New Horizons with Emily Lakdawalla. That was a pretty good show. Okay.
Kiki, are you submitting video or audio?
So that's the thing. We can
And
do
who are we
both.
submitting to? I was previously
NSF.
indisposed.
No, it's National Academies of Science.
Oh, nope.
National Academy of Sciences.
Not safe for work. Wait.
No, National Science Foundation is what I thought she said.
Oh.
National Academy of
That's
Science.
not what it
Yeah.
is, yeah.
Yeah. Cool. Yeah, I think it would be good to have both. So I think the audio for the New York episode from last year was good, right? It was just the video that was.
Oh, yeah, I'll have to go back and listen to it. But
Okay.
yeah,
I say
Because if that's the case, I think that was a really good show.
it was a
I
great
say you
show.
submit.
Yeah.
all of last year. We can win by attrition.
We can only submit 6 things, Justin.
I know. So
But
it's just,
so
wait,
here's
so let's submit 6 years.
no, but here's
6
the
years
thing.
of.
If individuals, it's only for 2015, things produced during 2015.
Okay.
If people other than say I pick 6 of my favorite, but then someone else can pick 6 different. So if we have a list that's longer of video and podcast and like all of the above, then maybe they'll look at all the nominations from people and like get the variety of everything that we do.
So then follow-up question. If people vote for all these different episodes, it doesn't matter that the episode that the voting will be diluted. They'll still total up everything for us.
Yeah, I don't know. I don't know how it works.
That would be my question, because we don't want to like put up like 30 episodes and then because of that we have one episode that has 5 votes and that's like the most votes we have on an episode.
Such game theory going on here. Yeah.
Yeah.
Well, it's a good question. I mean,
no, it's good. It's good strategizing. I'm not. Why do you think Why is it whenever I mention anything you talk about, you think I'm complaining about it? I was not complaining.
Why is that?
I don't know. I meant this in a positive.
Oh my God.
Like, yeah, maybe there is a strategy to this.
Well, maybe you should look at how you talk to me instead of pushing the blame back on me.
Words that came from my mouth hole sound maker, like, oh yeah, maybe there's a game theory to this. And then you're like, wow, why do you say
Is that what I sound like? Thanks.
That's funny.
So yeah, I think Blair's right, which is no disrespect. And,
See, if you just start the sentence with that, then I'll know that it's not. Blair was right. Let me say.
No disrespect. It's only 2 reasons you could be standing here right now, and one of them ain't it. So.
Oh my God.
So yeah, so I agree. Maybe we should probably pre-filter and then throw that out to the minions to propagate.
I feel like we need a great minion project. Actually, would be a reel.
Uh-huh.
That'd be a great minion project. It's just like a 5-minute reel of like best of, and we could use that even to just try to get other people to listen and watch, besides submitting to things.
Yeah. Identity 4 is saying that the audio of the 2015 New York show has a bad echo in the first few minutes, and I thought it did.
Oh yeah, we fixed it though. It repairs at some point during the episode.
Yeah, but if someone's going, click, I'm going to listen to the beginning of this, holy crap, what is that? They're going to turn it off and be like, these people don't know what they're talking about.
Yeah.
So I think more likely if we try and do this again next year, the New York show for 2016 will go in, but I don't think it can go in. But I think that the TWIS short could go in there.
From New York?
Yeah.
Well, what are they looking for? If they're looking for science communication, that one doesn't really have.
No, but it might be a decent enough intro into like the 5 episodes they would then have to delve into after, which is like, okay, now we've been sort of prepped for what we're gonna see, how it started and is conversational, and okay, so now we're.
Yeah. Have you read it at all yet? The nomination, the award.
No.
I don't know what you guys are talking about.
So
it
National Academy.
National Academy of Sciences, Engineering, and Medicine 2016 Communication Awards nomination form. Prizes of $20,000 will be awarded to individuals or teams who have developed creative, original works that address issues and advances in science, engineering, and/or medicine for the general public. Nominations are accepted in 4 categories: book, film, radio, TV, magazine, newspaper, and online. To be considered for a 2016 Communication Award, the work should be accessible and appeal to a broad public audience, demonstrate clarity, creativity, originality, and accuracy, address issues and/or advances in science, engineering, and/or medicine, cover topics that have an impact on society, and have been published, broadcast, or released in 2015 in the United States and in English.
Wow.
I think we win all of those categories. I don't think there's anybody else who can come close to. Like, who else? No, seriously. Like, we've hit on
So,
all topics. We've communicated online throughout 15, let alone all the other years when they didn't.
so it's not a Lifetime Achievement Award. It's just for 2015. The work for which a candidate or team is nominated must have been published or broadcasted in 2015.
I can't
So-
find it.
What do you mean?
The thing you're reading.
I just put the link in the chat room.
Oh, okay.
I'll do it again.
No, I can scroll.
You can scroll. I put it in there. I can do it again.
Oh, I see it. Okay.
Okay, you found it.
Wait, I don't see it. I don't have anything in there. Is it
Found
in the group chat?
Yeah, Ed from Connecticut. We were talking about the octopus show. That's
My
definitely going to
group
be
chat
one
is
of them.
empty.
Oh, thanks, Whiskey Renegade. I'm glad you liked this episode. I thought it was a good episode.
Yeah, I did.
Yeah.
Somebody asked me, speaking of cephalopods, now I'm reminded, in the show today they were asking about the size of brains that cephalopods have, because we were talking about animal brains and size and stuff. But one of my favorite things about cephalopods is that their brain is shaped like a donut, and it is teeny tiny, and they're essentially their trachea. I mean, they don't have a trachea, but they're like the tube in between their mouth and their like stomachy bits goes through their brain. And so if they swallow something too big, it bumps on their brain on the way down and gives them brain damage.
Oh,
Are you
poor
kidding?
design.
So that's their
More surface
brain.
area, but
then
bad design.
in recent years, they've also found that octopuses actually have something kind of like a brain, like they have a nerve ball in all of their 8 arms. So people have started to say that octopuses have 9 brains. So depending on what you call a brain, octopuses might have 9 brains.
9 brains.
Yeah.
I love it.
All right, send me a link to this thing.
Oh, the CRISPR hacking episode. I think that one was good too with Josiah.
Uh-huh.
Mhm. Also, the episode where I was like, we're going to be talking about this forever. Episode. Whichever episode that was.
What?
The episode where I was like, okay, CRISPR-Cas9, we're going to be talking about this forever now.
Right.
Like the first CRISPR, I don't know how the rest of the episode.
Teams of no more than 4 people. Yeah.
Right. We just
Oh
fit.
my goodness, we guys just made it underneath. Well, we maybe had a little room to grow. We could hide one person.
Posthumous awards not permitted. So
Okay, dead people.
we all got to stay around.
I hadn't really put it that way in my head, but yeah, nobody can die.
Nobody die, you guys.
It's always a good rule.
Yep. February 8th. That is soon. So what are we? Film radio, I guess?
Oh, we missed it.
Or are we online? Nice, Justin.
We missed it.
You missed it. Kiki, would we be online or film/TV?
I think we're online.
Okay.
That's what I think I mean, I
Or
think every
film/radio, excuse me, is what I meant to say.
Yeah,
They should have a podcast button.
I know.
National
Yeah, I mean, it's
Academy of
hard-
Sciences.
It's hard to say because, I mean, it could just be, we could be considered film, TV, radio because that's kind of what we do, but then, I don't know, somebody out there, nominate us for film, TV, radio. Why not?
What's the award called? Who is this? I don't have any links to anything. I don't understand what's going on. Yeah, like the categories at least you listed sounded like we were Unless they got more specific, like must have been wearing headphones and at least one member must wear glasses. I don't think it could be more specifically what we're doing.
No.
And you must have at least one person who wears glasses that don't improve their vision even though they need corrective glasses to see properly. That's how they could have refined it ever so slightly to really own the category.
Yeah. I don't know, but a couple of I don't know. I don't know.
All right, it's 10:30.
I'm tired still.
Look, Tony Steele sent me this for my birthday.
So cute.
Can you see it at all? It's shiny.
Shiny. Got the shiny lights on it. There. Oh, hippo birthday. How cute is that?
I know.
That's awesome.
I have to buy
That's really
frames.
cute.
Okay. Okay.
Okay, are we going to go? Yes, Minion Hangout tomorrow with Ed from Connecticut. Those of you who are still with us here. Minion
How
Hangout.
are we not even in the podcast awards category of science? Whatever this is. This is the 11th annual podcast awards, and we're not even listed under the science category.
Nominations opening in early 2016. So have they opened?
I know.
Oh yeah, this was from last year. It's basically I didn't pay any attention when the nominations got started, and pretty much you just have to tell people to vote every day, all the time. Like it's basically like, go vote for us, go vote for us, go vote for us.
No. We must know at least somebody who can create a voting robot.
Yeah.
Who can flip their
Yeah.
their something where it looks like their web is coming. Never mind. I don't know anything about technology.
Yeah, I just usually don't pay any attention, and then all of a sudden things happen, and it's like, oh, okay, I missed that.
Okay.
Oh well.
Say goodnight, Justin.
Good night.
Good night, Justin.
Good night, Justin. Good night, everybody. Thank you for joining us once again for another fun-filled science-y show. I hope that you have a fantastic end of your week. Celebrate International Zebra Day in style. Remember to send Blair, send us all, send them to @TWIS on Twitter.
I can't have zebras.
Yes, zebras. Send us zebras. We need Blair especially needs zebras, but we need
At Blair's
zebras.
Menagerie.
That's right, a zebra menagerie.
Is that how you say it?
Menagerie.
Menagerie.
I thought it was menagerie.
Oh dear. You guys out
Say goodnight,
there.
Justin.
Say goodnight, Justin. Audience, you are the best. Minions, we love you. We'll see you soon.